Thank you for joining us today. My name is Sim Whitehill. I work for VideoRay, and I am the offshore oil and gas manager here. I've been with VideoRay for more than 5 years and been in the marine industry roughly my whole life through a rope company. With me today, joining me remotely, is a gentleman named Will Boydum. Will Boydum is a naval architect and marine engineer. He has worked in the inland, coastal, and offshore marine markets, providing services such as vessel construction, conversion, and condition surveys. Will has worked with VideoRays since 2010, and he is currently our U.S. Gulf of Mexico dealer. Companies that Will has also worked with are Exxon, Stoll Partial Tankers, back again to Exxon under the Sea River flag, and has even worked for the Harris County Sheriff's Office. In addition to that, Will is a 20-year friend of mine, and welcome, Will. Today's presentation is the first of a series. Today's presentation is intended to be the overview, in which we're going to touch on about 7 different topics. So we're going to touch on the topics and move forward with them quickly. From here, we're going to begin a series of webinars where we go in more depth on each individual topic about once a month. So this is the overview, and there'll be more in-depth ones following throughout the balance of the year. Questions? During the presentation, you might have a question. Write it down. I believe that if you have a question, it stands to reason that there are other people on this webinar that might have the same question. So Kate McGarry will write it down, bring it up to me, and if it's on topic, we'll kind of stop and answer the question right then and there, because somebody else has probably got the same question in their mind. A little background on VideoRay before we get started. We're a nice company, founded in 1999. We're actually the largest volume manufacturer of ROVs in the world. There are people who make them bigger, but nobody makes more. We've gone through a lot of markets. We do law enforcement, military, aquaculture, but the focus currently, and the focus of this webinar, is on the offshore oil and gas market. Okay. Every year we have kind of a flagship project, and I'm going to be shutting off the webcam here in a minute because different people's internet connections process data at different rates. So you don't need to look at me when we're showing video. So we'll be shutting that off in a second. A major project that we worked on last year was the Costa Concordia. Worked with Titan Salvage. They had 6 ROVs on that project, 6 Pro 4 VideoRay ROVs on that project, which they logged more than 35,000 hours of use. To quote an exec from Titan, VideoRay products have been a key component of the success of the Costa Concordia underwater operations. What are we going to talk about today? The main topics that we're going to run through are ship husbandry, emergencies, UWILD/yard planning, sea chest regulatory inspections, jack-up inspections, ballast tanks, shallow subsea inspections. These topics all share one thing in common. How you deal with them. And everybody who works in the oil and gas industry cares about 2 things: time out of service and risk management. Time out of service is defined as staying on the well longer or getting back in station. Risk management is defined as risk to personnel, event management, and corporate image. I'm going to hand the technical nuts and bolts of this off to Will. Will, you there?
I'm here.
Everybody, Will Boydum.
Morning. I'll just run through several of these topics as we go. The first is a hull thickness survey. And this is a tool that was developed several years ago in response to the desire to be able to do close visual surveys of class vessels without having to put men in tanks. Part of that was development of an ultrasonic thickness gauge that would allow gauging on any surface. We now have, through allied companies, the ability to do general visual and close visual and UTM on ABS class vessels and soon DMV class vessels. What you're seeing on the screen is the center photo is the ultrasonic thickness gauge pressed against the side shell of an ABS class vessel. You see the date and time, you see a data line, and then the arrow is pointing at the hull thickness reading. That data is all stored on the video record for this inspection, so it is auditable. It can be turned over to class. It can be turned over to flag state if there's ever a question as to the veracity of the survey. It's also available as background information for future surveys if you're trying to look at wastage rates or compare conditions. And this is video of a gauge in operation on a drill ship. In this case, the ABS surveyor has asked that the ROV be returned to a particular T-junction in the tank and a thickness reading taken to verify repeatability. Things to notice are the detail on the lat plates and the fillet welds, the erection butts, the longitudinals. This tank is a coal tar epoxy tank, flat black, and it was filled with harbor water using the fire system. So these would be considered poor conditions, and yet the visibility is still excellent. The class surveyors were very impressed. You'll see the gauge will touch the side shell, actually in the heat affected zone, and the surveyor will ask that it be moved slightly. And there it is, the ultrasonic thickness gauge reading, 16.15 millimeters. The depth indications are also depth below water surface, and the second number is calibrated as height above the bottom of the tank. With the visual tools and the UTM tools available, you can do a lot towards UWILD and yard planning. We have done credit UWILDs for both ABS and DNV on typically on drill ships in service, so that they don't have to come off the drill string. You can also do your yard planning by taking your steel thickness measurements and getting good visuals ahead of time so that the spec is written much more tightly and change orders are minimized. The imagery front and center on the slide that you're looking at is thrusters on a drill ship that is actually drilling. We're able to go in and look at the sea chests and look at the thrusters while the drill ship's still working. This is imagery from a part of a UWILD inspection that was done on a trading tanker. See the anodes, the rope guard. This is a bilge keel inspection for a vessel on Lake Maracaibo. Again, water quality wasn't what we consider great, but you can see the veracity of the inspection, and very good imagery of the tip and the fillet wrap. Have the ability to inspect sea valves in service. We have an external camera that can actually be inserted inside the spool piece to watch the valve operate, check the valve seats. I'll turn it back over to Sim here for event management.
Event management has long been what I thought one of the best uses for a VideoRay and most valuable to the industry. What we have here are actually pictures of a ferry that had run aground in Puget Sound. And the original salvage plan was to grab a hold of the back of a tugboat and yank it off of what they thought was a sandbar. It just so happened that the local Coast Guard had a VideoRay with them at the time, and they decided to deploy it underneath of the vessel. And when they did, they found a ginormous rock protruding up into the hull. And if they had actually stuck with their original salvage plan, they would have destroyed the vessel. They would rip the nose of the vessel right off of it. Almost simultaneously, a major was practicing a simulated grounding in Puget Sound. And they were scrambling a response team from Houston to go out and respond to the simulated grounding. And someone in the van, as they were going off to the airport to Puget Sound, mentioned, you know, if we had one of these aboard that vessel, we'd already know what the problem is. It's a very powerful message that information can be brought to bear immediately. Will, back to you.
One of the biggest uses currently in the Gulf of Mexico for the VideoRay is compliance with the Clean Water Act EPA sea chest regulatory inspections. Sea chests are required to be inspected monthly or weekly depending on where in the Gulf the vessel is located. So while we're pleased to be a solution to a regulatory problem, our bigger desire is that people will recognize the utility of the tool once they have it on board and begin to use it in many of these other areas that we'll be identifying today. That's where we feel that the true value of the tool lies. This is imagery of a sea chest inspection done on a drill ship in the Gulf of Mexico. You can see the clarity of the imagery, the ease. The entire inspection takes typically about half an hour, 45 minutes from start to finish. You'll also note that the pilot takes a very strong interest in the marine aquaculture, and I think this becomes a fish finding expedition by the end. I'll look at some sea chest imagery from a producing spar in the Gulf of Mexico. For those of you that are susceptible to motion sickness, the beginning of this video can be a little disconcerting, but it does show the ease with which the video array can be launched. Simply lowered down on the tether, weighs about 13 pounds, so it can be handled by a single man safely. You'll note the clump weight on the down line there. There are a number of tips and tricks which we use to help manage current and other things during all of this inspection work. These are covered during VideoRay training, either on site or open enrollment training on shore.
Hey, Will, you brought up training, so let me chime in on that real quick, something I hadn't planned to talk about. But it's important to note that VideoRay has begun a partnership with the NASA Neutral Buoyancy Lab in Houston, Texas, to conduct training for this inspection. The idea is to make it convenient for your personnel to get there, and it's a fantastic facility to work in. Sorry, Will, didn't mean to interrupt.
I'm just watching the photography. The last video was a producing spar. This is the drill ship that we saw the still photo from earlier. This is probably one of the more difficult installations we've had to deal with because of the proximity of the sea chest to the operating thrusters. And the way the operator approaches this inspection is that they isolate the closest thruster. So the one in the foreground has been isolated. The other two are available to the DP system. Through the job planning, it's set up that the approach to the sea chests and the thrusters is from a direction that should the worst happen and the one of the active thrusters turns, it will simply wash the ROV out from under the vessel. And
hey, Will, I have a sea chest inspection question.
Sure.
You there?
I'm here.
What would you typically deliver to the customer on a sea chest inspection? Stills, video, or written report? You want to handle that one?
Yeah, typically on a sea chest inspection, that's actually being done by the vessel personnel because of the frequency. It just makes sense for a vessel owner to purchase equipment and train their personnel for something that has to happen on a monthly or in some cases weekly basis. And what we understand from most of our clients that are doing this is that they keep a video record on board of the inspection. Should they ever be audited by the EPA, they have the time and date stamped video showing each inspection that was done and the condition of the sea chest. Hopefully that answers the question.
Additionally, Will, the EPA is requiring digital reporting quarterly.
Correct. That's through their system, which I understand is simply a statement that, yes, we are doing the inspection, but yes, that is now quarterly, that it has to be reported. Do you want me to handle Jacob's sim, or do you want to take this one?
You're doing great. Go ahead. Okay. You're doing
Jackup inspection was done at the request of a customer who recovered a damaged leg and ultimately damaged the jacking gear in the process. So we've developed two tools for them. The first is the ability to perform visual and/or sonar inspection of the leg. It's a quick flyby type inspection to verify that all the truss cords are in place, that there's no large objects stuck in the leg, basically just looking for gross damage or gross problems prior to leg recovery to avoid future damage. What you're seeing here is a visual look at the leg. We can also do it with the sonar. The second tool that was developed from them, which I believe we have some imagery of later, is an automated survey tool. When rigs are being towed from position to position, their harbors of refuge are always nominated should the weather get too scuddy. In this case, and as is most of the cases, the customer recognized that the harbors of refuge often don't have bathymetry or have very old bathymetry. So using some of the tools of the VideoRays developed for the Navy, we have created an automated utility. You throw the VideoRay over the side of the platform, then it pieces together over a period of anywhere from 20 minutes to 80 minutes, depending on the level of detail required. It pieces together a knit sonar image of the bottom, looking for debris, prior spud can holes, pipelines, anything that might be on the bottom, and gives the operator a map, a geo-referenced map, so that they can set the legs down in a safe place. In this particular sample, they found a very large rock on the bottom, 40 feet high, that would have been a problem had you tried to set a leg on it. Ballast tank inspections is another big area, especially as it relates to safety of personnel. One of the oil majors started a number of years ago with a JIP, and VideoRay has been the technology provider to that JIP. The stated goal was to keep men out of tanks, recognizing that that's not always a complete possibility. The idea is that the tanks can be triaged, the majority of the inspection work can be done, and only those tanks with identified issues need to be entered. As mentioned earlier, we have done general visual and close visual inspections that have been credited for ABS using the ROV. On this image, the black circle to the left there in the image is actually the part of the UT gauge that we discussed earlier. So in this case, they're doing general visual, close visual, and taking thickness readings all at the same time. The tank in question is the aft-peak tank on a trading tanker. This video is a ballast tank on a producing spar in the Gulf of Mexico. Again, doing general, close, and UTM inspections. The VideoRay is fitted with a 700-line TV camera that most of the inspection work is done with, and that all of the telemetry feeds back through and is recorded. The imagery that you're looking at now is from an external HD camera. While this imagery can't be looked at real time, it can be recovered at the end of the mission and compared to the nose camera if there's a particular area of concern where you want greater detail or greater visibility. basically anything at 300 meters or less can be looked at with a VideoRay. We have the ability to fit an external monitor. In the case here, they're setting a wellhead assembly. It's great video because actually the VideoRay was expected to be destroyed during this operation. You'll watch the BOP come down and actually go into latch up, and then at the last minute the pilot will back out very quickly with the VideoRay, so the VideoRay was recovered. Yeah, anything that needs to be observed in the shallow range, 300 meters or less, whether it's at the seafloor, at the wellhead, whether it's mooring chains, mooring risers, anchor assemblies, swivels. The VideoRay is a perfect tool. It's very small. It will fit inside of a riser bundle. It will fit inside of buoyancy cans. So it's a very good tool for inspecting the uninspectable. I had a number of gas production jackets that were set where the remote monitor was placed in the crane operator's cab so that he could respond in real time in positioning the jackets over the piles.
Okay. We've been talking about individual tasks so far, but the VideoRay is all about gathering information. Information is power. If something goes wrong, if you've got the information, you have the truth. Sort of. What we have here is a portion of a CNN newscast that was done after the incident in the Gulf a few years ago. When the incident happened, CNN had to have a VideoRay, had to have one, and needed an operator. So they hired an operator out of New England to go into the Gulf of Mexico and look for damage, something that they could report on CNN. The picture on the left, it's interesting, they went out for several days, yet CNN did not roll any video footage. They only used still pictures. If you look at the image on the left, the dialogue in the newscast alludes to that the blob in the foreground is a drop of oil on a rig that is 100 miles from the spill, and that there's no sea life in this picture, and we'll never know the price of this spill. But if you look at the timestamp is 1:50:25. In 3 minutes later, this is the exact same rig, the exact same leg, and that's the picture. They close the news story with, very grim words that perhaps we'll never know the true cost. And they show this picture with this black fish looking very dead. This black fish is in fact a black wrasse that lives its life on its side, and it is very alive. Having the VideoRay aboard when there is a problem affords you the ability to live with the truth. So today we've touched on, again, this was an overview, hull thicknesses, U-wild, yard planning, sea valve, event management, sea chests, jacket leg inspections, and ballast tanks. Well, first off, I'd like to thank Will for joining us. It's nice to have such a strong professional around to help us out. And second off, I'd like to thank you all for your time. I know you're busy. I appreciate you spending about 45, 50 minutes with us today. Thank you much, and we look forward to seeing you for the next one.